Students, today's topic derivation of second law. So on previous video we discussed Kepler's laws and derivation of first law. So here today's derivation of second law. So consider the planetary motion. Let here S is the center of the sun. So P is the center of the planet in its orbit. Let R vector is the radius vector of the planet with respect to S. So here R is the radius vector of the planet with respect to S. The planet moves from P to P dash. So ఇక్కడ ఉన్న planet moves from P to P dash. ఇక్కడ ఉన్న time, so certain time delta t అనుకుంటే, so planet moves from P to P dash in small interval of time. So here the vector area delta A swept by the radius vector in time interval delta t. So delta A of R delta R vector dividing both sides by delta t. One can obtain, so dividing both sides with the delta t. So dA by dt we can write like this: rate of change of aerial velocity of R bar into dr by dt. So here rate of change of position vector dr by dt, rate of change of position vector is equals to velocity. So according to this formula we can write dr by dt replaced by v. So next on RHS side, multiplying dividing with m, so 1 by 2m r bar into mv. So we know that mass into velocity, so mass into velocity is momentum, p is equals to mv. So here it is in rotatory motion, so mass into velocity is angular momentum L. So mass into velocity is angular momentum L, mv is equals to L, so 1 by 2m L. Next here L is a constant for a central force, so dA by dt is equals to constant. So L is a constant kabatti, so total aerial velocity also constant under central force. Thus the aerial velocity is constant. This proves the Kepler's second law of motion. So next third law, consider the semi-lattice rectum L of the elliptical orbit. A and B are semi-major and minor axis. Here A semi-major axis, B semi-minor axis of the ellipse respectively. So L is equals to P square by A. So H square by GM. It is, if T is the period of planet around the sun, so area of ellipse by aerial velocity pi AB by H by 2. So squaring on both sides, T square H by 2 whole square అంటే H square by 4 పైకి వెళ్ళిపోతుంది, 4 pi square A square B square by H square. So here 4 pi A square B square by H square అంటే ఇక్కడ H square ప్లేస్లో ఇంకా H square ప్లేస్లో ఏం రాసుకోవచ్చు, B square GM by A, B square GM by A. సో here B square క్యాన్సిల్ అయిపోతుంది, 4 pi square A cube by A ఉంది కదా, A పవర్ 1 ఉన్నట్టే, సో పైకి వెళ్ళిపోతే A cube by GM. So here 4 pi square GM is constant, so T square proportional to A cube. Thus the square of the time period of the revolution of the planet around the sun is directly proportional to the length of the semi-major axis of the elliptical orbit. This is the third law of Kepler's.